So now that we've seen how we can solve our integration using the substitution method, now let's look at by parts method. So what generally happens in by parts is that whatever integration has been given to us, it would be, let's say, two types of functions there. So we have to identify two different functions in our entire function that has been provided to us. So we consider one to be u, one to be v, and then what we do is we first identify which one we are going to choose as our u and which one we are going to choose as our v. Then what we do is we first write down u as it is, find out the integration of v dx minus integration of u dash, we differentiate u, and inside the entire integration we write down the value of integration of v dx, and this is entire dx. So this is how we use our by parts integration to solve any type of integration function we have. Now what would be our conditions to choose our u function and v function? So generally u function is considered to be high priority functions, and v are those functions which can be, let's say, integrated easily. That is why we have like integration of v dx. U is something which can be differentiated easily. So generally it is not that you can assume any function according to you. There is a priority order as well for you to assume such functions. So this is the priority order for you to choose. This is the priority order to choose u function. Now here remember this thing that priority is going downwards. So that means first whatever function, let's say if you see an inverse trigonometric function in the entire function given to you, that means this is what you are going to choose as your u. If let's say there is no inverse trigonometric function, you see a logarithmic function, then this one would become u, then algebraic, then trigonometric, and then exponential. Now to remember this, of course, we call it as the ILATE rule so that you all can remember. And let's say if you have any constants there, let's say I have a huge function and I cannot segregate it to two different functions. So what I'll do is I'll assume one function to be whatever u or v, and the other one would become my constant. So after e, we would have constants which we can choose. So keep this thing in mind. Let's look at a question. So here we have integration of cos ln x. So we know that integration of cos ln x, we cannot integrate it directly, right? So what I'm going to do, I'm going to use the by parts integration. So here I can assume that this thing is multiplied with a 1 as well. So I'm assuming that this 1 to be my constant. So of course, this would become my first function and this would become my second function. Or I can call my first function to be u and my second function to be v. So now if I apply my by parts integration, how am I going to write this integration now? This would become u as it is. U would be written as it is. Then we would have integration of v. So integration of 1 dx would give us simply x minus integration of, here now we would have differentiation of u. What would be the differentiation of u? Minus sine of ln x, and then using chain rule ln x would be differentiated as x, and here we would have integration of v dx. So what is our v1? So we would have x again here, so this would become dx. Now here you can see that x and x gets cancelled out and we are left with cos of ln x into x minus of, sorry, this would become plus integration of sine ln x dx. Now again you can see that sine ln x is something which you cannot integrate directly. So again I'll use my by parts, assuming that there is a constant 1 multiplied here. So this would be my u and this 1 would become my v function again. So here again I'll apply the same function again, plus here what am I going to have? U as it is, sine of ln x into x minus of, what am I going to have here? Integration of, what would be the differentiation of sine ln x? It would become cos ln x upon x, and again I would have a multiplication x here. So this and this would get cancelled out amongst each other. Now if I look at this equation carefully, again I am left with integration of cos ln x dx, which was exactly what I was trying to find in the starting. So what if I call this entire integration with this variable I? That means this function that I've gotten, this is nothing but my I. So I can write this integration as I is equals to cos of ln x into x plus sine of ln x into x minus I. So I hope you are understanding how I'm doing this thing. So now what I can do is I can simply take this I to the other side. I would have 2i is equals to x taken common, cos of ln x plus sine of ln x, and I would have a constant of multiplication here as well. And what was I trying to find out? I was finding out my I, right? So it would simply become x by 2 cos of ln x plus sine of ln x plus c. So this is my answer. This is the exact integration that I was trying to find out. So I hope you must have understood this thing. Whenever we apply by parts, it is not necessary that after, as soon as you apply by parts in the first time only, you would get your answer. You might have to apply the by parts second time as well. And after applying the by parts second time, you might also get the initial function that you were trying to integrate. So what you'll do is you'll assume that to be I and then solve your integration. So keep this uh, terminologies in mind. Let us look at one more question. If I of x is equals to this and I0 is this, then I of pi by 3 is. So basically, again, we need to find out what our I of x is. So I'll multiply this e to the power sine square x into both my functions and see what I'm getting. So I would have I of x equals to integration of e to the power sine square x cos x sine 2x dx minus, I've taken the integration separately for both these terms. So this would become e to the power sine square x sin x dx. Now what I'll do is, in this entire function, I can see that e to the power sine square x and sine 2x seem to be together. Of course, I need to assume them to be together because if I, let's say, differentiate sine square x, what am I going to get? 2 sine x cos x, and 2 sine x cos x is basically sine 2x. So I need to keep them together and I'll keep my cos x separately. So what I'll do is, I will write it down as e to the power sine square x sine 2x. I'm just keeping these two together and I have cos x dx minus this remains as it is the way it was, e to the power sine square x sin x dx. Now here you can see that I can again apply my by parts in the first term. Now what am I going to choose as my first equation? Of course, if we look back, I had a trigonometric function above exponential function, right? So now I'm considering this sine 2x to be a part of this exponential function only because its differentiation is below, right? So I'm considering to be this to be one function only. So this is my exponential, this is my trigonometric. So of course my trigonometric would be considered to be my first function. I will consider this to be my first function. This would be my second function. That means this is my u basically and this is my v. So now let me write down the by parts integration from here. U would be written as it is, where I would have integration of e to the power sine square x sine 2x dx minus of integration of differentiation of u. So it would become minus sine x. So here I would have minus sine x into integration of e to the power sine square x sine 2x dx, and this entire thing is under dx as well, right? And I have my separate function here, which is e to the power sine square x sin x dx. So now for the first portion only, now I'm still considering the first portion, this minus e to the power sine square x sin x dx, I'm just leaving it aside for the moment. I'll solve that later on. For the first portion only, what I can see is sine square x and I have its differentiation below. So I can assume sine square x to be t. So I would have 2 sine x cos x dx is equals to dt, which is nothing but sine 2x dx is equals to dt, right? So now I'll start replacing the values. Here I would have is equals to cos of x integration e to the power t dt minus, sorry, this would become plus, we would have integration of sine x, and here inside the integration we would have e to the power t dt again, and this entire thing is dx minus, I'm leaving this entire function to be the same as it was before. I'll try to solve this later on and let's see if there's some pattern that I can see or not. So simply e to the power t can be integrated as e to the power t only. So after I get e to the power t, I'll replace my t as sine square x. So this would become cos x e to the power sine square x plus, here what am I going to have? Integration of sine x e to the power sine square x dx, and minus integration of e to the power sine square x sine x dx. So now if you look at these two functions carefully, this term and this term, they are similar. The only thing is that it is multiplied in the separate order, so they are same. That means one is negative, one is positive, so this can get cancelled out amongst each other. These two terms would cancel out amongst each other, and we would be left with cos of x e to the power sine square x plus c. So now you can see that we've integrated our entire function successfully. We've received a value that was similar to our negative value that was given in the question. They got cancelled out amongst each other, and now we are left with this. Now in the question, they've told us that I of 0 is equals to 1. Now this information is given so that we can find out what our constant c is going to be. So 1 would be equal to, if I put 0 in this entire equation as x, so I would have cos 0, which is 1, e to the power sine 0, which is 0. So this would also become 1 plus c. So here I get c to be 0. That means I get my final function I of x as cos x e to the power sine square x. Now what was asked to us in the question? We had to find out the value of I of pi by 3. So I of pi by 3, this would become cos of pi by 3 e to the power sine square pi by 3. So from here, what do we get? Cos pi by 3 is 1 by 2, and sine pi by 3 is root 3 by 2. So it would become 3 by 4. So e to the power 3 by 4. So this is our final answer. So this is how you solve questions which are related to biparts. Again, whenever, let's say, you can see the differentiation of some function, so you consider that entire thing to be one function. You can consider it to be v or u based on your priority order, as we had studied in ILATE. Based on that, you solve your biparts equation.